Good day, students. Today I want to solve problem on the topic titled Action due to force of gravity when an object is thrown up. It's a problem in physics that often confuses students. But let me analyze it. Take note of this condition. When an object is thrown up, this is an object, a ball is thrown up. It's going against the force of gravity. Because of that, your uniform acceleration is uniform on the straight line. When an object is moving on the straight line, when a car is moving on the road, that's uniform, is going through uniform acceleration. But when you are throwing object up, the acceleration will change to minus g because it's dealing with force of gravity. Is that okay? And when it's going up, it's going against the force of gravity. That's why when you see object going up, it's trying to come down. There's a force resisting it to come down. That is minus g. And at the point where it gets to the top, that it stops before coming down. The point of stopping, that's the final velocity v, which is equal to 0 because it's resting at that point before coming down. Now the opposite of it is when an object is on a cliff, for example, on the top of a mountain, and when it's on the top of the mountain, you now drop it. Your initial velocity at the point of resting before releasing it, u equals to 0, because it's supporting the force of gravity. It comes down faster than when going up. Your acceleration, you change it to plus g. Is that okay? This one is object, when you throw up, is coming with an initial velocity, but when you get to the top, it rests before coming down. And the distance at which it goes up is same as when it comes down. The time taken will be 2 times t. Okay? T, 2 times t. Now, let's now solve the problem. An object is thrown vertically upward. Immediately you are told that an object is thrown vertically upward, have it at the back of your mind that the final velocity is 0, that is v equal to 0. But when you are told that an object is released from the top of a cliff or from the top of a mountain, always know that at the point where it's being released, u is 0. Initial velocity is 0 because it's resting at that point. But here we are taking note of v equal to 0 because being thrown up. Initial speed, u is initial speed, 20 meters per second. Acceleration, take it minus g because it's being thrown up, because of minus 9.8 meters per second squared. Time to reach the highest point, that is t top. That's what you are looking for. Maximum height, s equals to h maximum, s maximum, same thing, question mark. Time of flight, total time of flight, t equals to 2t, that is question mark. When you get the t top, you multiply it with 2, you get the total time of flight. You have velocity at 2 seconds, I'm looking for that. Displacement s at 3 seconds. Okay, now let's solve the question. It's very important to write the parameter first. Now, time to reach the maximum height, v equals to u plus at. The first equation of motion, which is our v is 0. Now before then, u plus a, change it to minus g, multiply by t, equals to u, positive and negative give us negative gt. Our v now equals u minus gt. What is our v? Is 0, u 20 minus Since you have written minus g here, you don't need to write negative again. This one has taken over of minus g. Just put everything here and there. Minus 9.8 t. Take minus 9.8 across the equal sign. 0 plus 9.8 t equals to 20. 0 plus 9.8 that's 9.8 t equals to 20. Divide both sides by 9.8. Cancel each other. Your t top now, because I divide it, you have divide that, you have 2.04 seconds. Okay, now the second part, the big part of it, maximum height reach. Use v squared equal to u squared plus 2as as one of the equation of motion. Now v squared equals u squared plus 2 multiplied by minus g by s. V squared equals positive and negative give you negative, u squared minus 2gs. Since you have substituted minus g here, okay, for you not to be confused, let's do it like this. I don't want you to be confused. Let's just say a equals to g equals to 9.8. But when you get to this point, just substitute the value of g directly. Is that okay? The reason why we introduce negative here is because it's more going up, going against the force of gravity. But normally your a equals to g and equals to 9.8. Okay. Now have v squared. We are looking for s. V squared is 0 squared equals 20 squared minus 2 times 9.8 times s. 0 squared is 0 equals 400. 20 squared is 400. 9.8 times 2 times is 16. That's 19.6 minus 19.6 seconds. Let's take minus 19.6 seconds across the equal sign. Negative change to positive. 0 plus 19.6 seconds equals 400. 0 plus 19.6 seconds, that's 19.6 seconds equals to 400. Divide both sides by 19.6. 19.6. Cancel each other. Therefore, our maximum height, x maximum, which is equal to h maximum, because you press your calculator very well, equals 20.41 meters. The third part is c, and we can use another formula to get the distance, or use this method. S equals to ut plus half at squared, which is equal to ut plus half multiplied by g half gt squared multiplied by minus g t squared. S equals ut, positive and negative give us negative, half gt squared equals, what's our u? U is 20. U is 20. And don't forget that our u is 20. You can see it here. The p part, whether use this v square equal to u square minus 2g, which is third equation of motion, or use the second equation of motion, times t. What our t? T top 2.04 minus half times 9.8. Don't forget this one. We change this positive here to negative because it's going against the force of gravity, times t squared, and our t, we have it to be 2.04 squared. This time, because when you multiply this, we're having 40.80 minus half times, when you multiply everything and divide by 2, you have 20.39. You have 20.41 meters, which is the same thing as what you have here. Okay, now let's go to the third part, time of flight. Time of flight equals to 2 times t top times t top. Times is symmetrical. Time to go up is if there's time to come down. Symmetrical. Okay, now we have 2 times, what's t top? 2.04, which is equals to 4.08 seconds. Now let's go to the deep parts of it. The deep parts, velocity after 2 seconds, which is u plus at, because u plus minus gt equal to u, positive and negative give us minus gt. Velocity after 2 seconds equals u is 20 minus 9.8 times, don't forget, change it to negative because it's going against the force of gravity, it's being thrown up, times 2 equals to 20 minus 9.8 times 2, that's 19.6, which is equal to 0.4 meter per second. Okay, upward. Positive sign that you have here, positive sign means it is barely upward. The ball is still barely upward. When you throw the object up, I told you that when it's coming down, when it's almost reaching the ground, that's why it is positive. Okay, the distance after displacement after from the ground after 3 seconds, which is ut plus half at squared equals to ut plus half minus g, going upward again the force of gravity, s 3 seconds equals ut, positive and negative give us negative half gt squared, or u is 20 times all our time 3 seconds minus half times 9.8 times 3 squared. Square the time. As 3 seconds equals 20 times 3, that's 60, minus half times 9.8 times 9. Displacement from the ground after 3 seconds, we have 60 minus 9.8 times 9, that's 88.2 divided by 2, which is 60 minus 44.1. As 3 seconds equals 15.9 meters upward from the ground. Upward from the ground. So when you throw the object upward, still after 3 seconds, the distance you see the ball, still 15.9 meter from the ground. Now it's coming down backward. That's why I see it is positive, upward from the ground. But for this, you can see this velocity after 2 seconds is positive. That's 0.4 meter per second. It's positive. So barely about to reach the ground. About to reach the ground. After 2 seconds. Velocity after 2 seconds is this 0.4 meter per second. Positive sign means it is barely upward. Okay, barely upward. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.